Here we have practice solving linear equations by graphing or elimination. So, we graphed the other day. If we have equations that are in slope-intercept form, it's easy to graph and determine where the lines intersect. That is our solution. If we don't have lines in slope-intercept form, then we're going to try to work on the elimination method, where we either try to get rid of the set of x's in both equations or the set of y's. Once we do that, we can solve for the letter that's left and then substitute that back into an original equation and then solve for the other letter. So it's going to take practice. Now, you need to do this work on another sheet of paper. You don't have room to do it on the actual sheet that I had you save to your thought folder. Now, even if you print it, it's pretty tight. You should have graph paper. If not, go on Google. Go ahead and copy or save one of the Google images and put it into your Paint program and save it there. Then you can simply use Paint straight line tool to graph. But it's always easier just to have, the paper pencil sometimes. So let's begin. So here I have y equals 1/3 x minus 4 and y equals negative 7/3 x plus 4. Well, notice they're both in slope-intercept form. So this is the perfect problem to graph. So I'm going to change that into plus negative 4. Now the only problem with graphing is if it doesn't cross at an intersection where I can identify the x and the y and not have fractions, okay, then I can use graphing. If not, I have to use the elimination method. So let's try it. So first I have negative 4 as my y-intercept. And then my slope is 1/3, so up 1 over 3, up 1 over 3. Okay, next one. My y-intercept is 4, and my slope is negative 7/3, so down, so actually up 7 and over 3, but since I run out of room, I'll go down 7 and go in the opposite direction over 3. Okay, down 7 in the opposite direction over 3. So there are my two sets of points. So this one goes like that. Make sure you use a straight edge and extend it. You got to be pretty exact. This one goes right here. Okay, so you can see that it crosses right there. It looks like it does. So what is that point? That's over 3 and down negative 3. So that's what we think is our solution. Over 3 and down negative 3. So we need to check this, especially when we graph. So to check it, we substitute the x and y back into one of these equations. So let's do the top one. So we said y is negative 3, so that goes right there. X is positive 3, so put that where the x is. Then add negative 4. Now we just do order of operations. So I have negative 3 equals, okay, got to be able to compute fractions. So I have 3 on the top, 3 on the bottom. So technically those all cancel. I'm left with 1. And then I have my negative 4. So I have negative 3 equals 1 plus negative 4 is negative 3. Check. So I know this is correct. Number 2. All right, well, notice these aren't in slope-intercept form. So we're going to shift to the elimination method. So let's do our same change opposite. Okay, let's rewrite these so we can line them up. Negative 7x. And what you're looking for are coefficients of the same x or the same variable that are opposites. So we're going to add these. Well, notice right here I have 7x and negative 7x. Those are opposites. So if we add those, we know they cancel. From all of our previous work on solving equations and moving variable terms from one side to the other, we always know we do the opposite sign. So they cancel. Great, they're gone. So now let's add negative y, and 5y is 4y. Negative 10 and negative 6 is negative 16. And now we just solve this. You can see why being able to solve equations is so important now. Y equals negative 4. Okay, well, if I know y is negative 4, I'm going to need to substitute that back into one of these equations to find the x. So let's just choose this one. So I have negative 7x plus 5y. We know y is negative 4, so substitute it. And there, now we have an equation we just solved for x. So negative 7x plus negative 20 equals negative 6. Again, you can see why it's important to be able to solve equations. Do the opposite of the number. And then, like we practiced, opposite of the operation. And x equals negative 2. So our solution for this problem is the point where x is negative 2 and y is negative 4. Now when you do it mathematically, there's not as much need to check it because unless you made a calculation error, you're going to be right. And I'm only going to check all of the odds today. I'm going to assume that if my odds are right, I'm probably doing okay on my even. So we're going to assume that one's correct. Number 3, we have an equation where y is by itself, slope-intercept form, and then y equals 7 is a special equation. So great, I can graph. That's easiest. So let me go ahead and grab my graph. Okay, so let's do this first one. My y-intercept is negative 9. My slope is 8, so up 8 over 1, up 8 over 1. Go ahead and graph that. Okay, and now we know this is a special equation. Y equals 7 means I'm crossing the y-axis at 7. So that means it's going to go this direction. And we see that our intersection is right there. Looks like it's a good one. So that's over 2 and up 7. All right, let's go ahead and check this, though, because we graphed. So let's go ahead and substitute 2 and 7 in. Now notice this 7, if I put here, would have been correct. So automatically I know y is 7. Okay, that's an easy one. I didn't really tell you that, but when you have y equals or x equals to a number, you already know what it is. But we still need to check the x. So let's substitute y is 7. We have 8 times x. X over here is 2. And then that equals, okay, negative 9. So 7 equals 8 times 2 is 16 plus negative 9. So 7 equals 16 plus negative 9 is 7. So check. So we know that's correct. Number 4. Okay, neither of these is in slope-intercept form, so let's use our elimination method. So let's rewrite them. 2x plus 3y equals negative 12. And then negative x minus 3y equals 18. Do our same change opposite. Okay, we know that we're going to add. Now, I have a 2 and a negative 1. Those aren't opposites. I have a 3 and a negative 3. They are. So we know that these are going to cancel. So now we're just dealing with the x's. 2x and negative x is just x. Negative 12 and 18 is 6. Oh, that was easy. So remember, now we have to substitute 6 back into one of these equations and solve for y. So let's do this one. So x was 6. And 3y equals negative 12. Do your math. So 12 plus 3y equals negative 12. And now we have a two-step equation. You obviously want to keep this here. So let's get rid of the 12 by doing negative 12. 3y equals negative 24. Divide by 3. Y equals negative 8. So all of this work comes from that whole month of December when we solved equations. So my solution, where these lines, if I graph them, would intersect would be x is 6 and y is negative 8. And again, if I wanted to double check, I would substitute both of these back into one of these equations. But since I'm doing the elimination method and it's calculations only, I'm assuming unless I made a mistake there that this is correct. Whereas when I do the graphing method, it's visual. I might be off a little bit. Okay, number 5. Okay, neither of these is in slope-intercept form, so let's do the elimination method again. Negative x plus 5y equals negative 16. Negative 3x plus 7y equals negative 8. Okay, so I have a negative 1 and a negative 3. Well, they're not opposites. I have a 5 and a 7. They're not opposites. Oh, so I have a little problem here. Well, what I have to do now is I'm going to have to make my opposites. So it's usually easier to take one of the smaller numbers and make it an opposite of one of the bigger ones. So I want to make negative 1 the opposite of negative 3. The opposite of negative 3 is positive 3, correct? So what would I multiply negative 1 by to make it a positive 3? Okay, math fact. I'd multiply by negative 3. If I do it there, I have to do it to everything. So now my new equation for this is negative 1 times negative 3 is positive 3x. 5 times negative 3 is negative 15y. Negative 16 times negative 3 is positive 48. And then I still have my old one. And notice, there we go. Now they're opposites. So sometimes we have to add a step. We know we're going to add. Okay, 3x and negative 3x, cancel. I have negative 8y here, positive 40 there. Go ahead and divide by negative 8. Let's see, it does come out. Nice. 40 divided by negative 8 is negative 5. So now let's take that negative 5 and substitute it back up here. So let's do this one. Negative x plus 5 times negative 5 equals negative 16. Negative x plus negative 25 equals negative 16. Okay, got to get rid of the negative 25, so do a positive 25. Please remember, this is going to take practice. Don't get frustrated. If all you can do is copy what I'm doing, that's fine. We're going to do more work in class. Okay, remember, whenever we have a negative variable, we need to make it positive. So if I change the sign on this side, I have to change it on that. So my answer is x equals negative 9. So my solution, negative 9 for x, negative 5 for y. Okay. Oh, here we have equations that have y by themselves, so we can go ahead and graph. Nice. Okay, so let's do this one. We have our y-intercept of 6. We have our slope of negative 1, 4. So that's up 1 and to the left 4. Up 1 and to the left 4. So there's our equation there. Okay? And the next one is a special equation, y equals 4. So we know that's a line that crosses the y-axis at 4. Now notice we're a little bit off. Well, not quite. It looks like it crosses right there. So that's over 8 and up 4.
Middleton to the office.
Now, because we're graphing, we need to check this. So let's take our 8 and 4 and substitute. Now, we already know the 4 is correct, right? Because it tells us y equals 4. So in order to figure out if x is right, we still have to substitute. So y is 4. We have negative 1/4 times the 8 plus 6. So 4 equals, negative times a positive is a negative. Okay, we can go ahead and simplify here, right? 4 goes into 4 once. 4 goes into that twice. So we only have 1 times 2 on the top, 1 times 1 on the bottom, which makes 1. Got to be able to do your fractions. And then we're adding 6. So 4 equals negative 2 plus 6 is 4. That checks out, so we know that's correct. Okay, number 7. All right, again we have equations with y by themselves, so we can graph. I like these. Okay, let's do our same change opposites here. So we know our y-intercept is negative 3. We know our slope is 4/5, so up 4 over 5, up 4 over 5. We graph it. Okay, we know that y is negative 7, so that means it's a line that crosses the y-axis at negative 7, so that's down here. And when you have graph paper and you're careful about how you draw your lines, you generally have very clean points to identify. So that's right there. So that's over negative 5 and down negative 7. Over negative 5, down negative 7. So let's check that. Well, automatically we know the negative 7 is right because they tell us. So let's substitute it up here. So y is negative 7 and x is negative 5. And then we're going to add negative 3. So I have negative 7 equals, okay, positive times negative is a negative. This time 4 times 5 is 20. 5 times 1 is 5. So I'll actually write that down. Okay, instead of doing it all in my head. So I have negative 7 equals, well, we have a negative, and what's 20 divided by 5 is 4. You know, you have to do as many steps as you need. You don't have to cut corners if you don't want to. Then I have negative 7 equals negative 7. Checks out. So my solution is right. All right, so here we have number 8 where I have both in slope-intercept form. So let's go ahead and change this to plus negative 1. So let's graph this top one. My y-intercept is 4, and my slope is negative 3, 4. So up 3 and over 4 to the left, up 3 and over 4 to the left. So let's go ahead and graph that one. Okay, there we go. And let's go ahead and graph this one. So my y-intercept is negative 1. My slope is negative 1/2, so that's up 1 and over 2, up 1 and over 2. All right, I can see something's going to happen. I wonder if you can. Uh-oh. Notice when I graph, I'm not reaching my intersection. So even if I were to extend this out, since my graph isn't big enough, I would only be able to estimate. So either you have to get a bigger graph, or if this were multiple choice, I might at least get an estimate. So that looks like that would be over 10, 11, 12, 13, 14, 15, 16, 17, 18, maybe over somewhere x is 19 or 20. And then obviously if this is negative 10, it might be like negative 11 or something. So we're thinking maybe somewhere around negative 19, or I'm sorry, positive 19 and negative 11. Well, that's not good enough. I guess we could guess and check, but we might do that quite a few times. Instead, I'm just going to use the elimination method. All right, so I'm going to change the equation so we don't have fractions. So remember how we do that? I want to get rid of the 4 on bottom, so I'm going to multiply everything by 4. So my new equation here will be 4y equals, okay, I have a negative, the 4 divided by 4 cancels out, then I have a negative 3x. Then I have my 4 times 4 there is 16. Fraction gone. We've learned that. Okay, I want to get rid of the 2, so I'm going to multiply everything by 2. So I have my 2y equals, okay, the 2 and the 2 will cancel, so I have my negative 1x plus negative 1 times 2 is negative 2. Okay, so now this problem is like one of the ones I've already had. So notice 4 and 2 aren't opposites, and negative 3 and negative 1 aren't opposites. So we need to create opposites. So let's take my 2, my smaller 2, and make it to the opposite of 4. So what's the opposite of 4? Negative 4. So what do I multiply 2 by to make it into a negative 4? And obviously it's a negative 2. So do that to everything. So now my new equations again are, here's 4y, this one stays the same, but now this one changes to a negative 4y, negative 1 times negative 2 is a positive 2x, okay, negative 2 times negative 2 is a positive 4, and now we can add them up. We know these will cancel because they're opposites, so I have nothing. Negative 3 and positive 2 is a negative x. 16 and 4 is 20. Okay, let's get the x over on that side so it's all by itself. So I have x equals 20, which we thought was 19, so we're pretty close. So now let's take that 20 and substitute it back into one of these equations. So let's do just this one. So I have y equals, I have negative 3/4, I know x is 20, and I'm adding 4. Okay, so y equals, well, I have negative 3 times 20 is negative 60. 4 times 1 is 4. So y equals, that's going to be a negative, 4 goes in there 15 times. And so finally y equals negative 11, which again is pretty close to what we thought, huh? So my solution is x is 20 and y is negative 11. So sometimes, even when we graph, it's not going to work out like we want. Either the graph isn't big enough, or we might cross at a place where we can't identify. So 1 through 8 is all we needed to do. We'll work on 9 and 10 maybe tomorrow as a little quiz, so you might want to do them on your own. So please remember to take the quiz on Edmodo after you do these notes.